Welcome everyone. Myself, Dr.Jignesh, working as a professor in Department of Quality Assurance at LJ Institute of Pharmacy. Dear students, in today's class, we'll be focusing on UV visible spectroscopy. In today's class, the contents are as follows. We'll be starting with the introduction to electromagnetic radiations, followed by characteristics of electromagnetic radiation. We'll be focusing on some important terms and definitions with respect to electromagnetic radiations, and we'll also focus on EMR spectrum, that is the spectrum of electromagnetic radiation. Now, starting with the introduction to electromagnetic radiations, as all of you know that light, it is a form of energy, and it is also known as electromagnetic radiation. Now light, it travels in the form of a wave known as electromagnetic wave, and it was proposed by wave theory of light. The wave theory of light proposed that light, it travels in the form of a wave known as electromagnetic wave. Now this electromagnetic radiation, it is a form of energy. It is associated with energy, and this is mainly produced by oscillating electric field and magnetic field. So due to oscillation of electric and magnetic field, electromagnetic radiation is formed, which is associated with energy. It is also formed by movement of electrically charged particles, that is by the movement of electrons. So by the movement of electrons, which is an electrically charged particle, electromagnetic radiation can be formed. This theory of electromagnetism was developed by James Clerk Maxwell. The electric and magnetic fields which are being formed in electromagnetic radiation, they come at right angles to each other, means they propagate in the form of a right angle with respect to each other. Hence, we can say that if you consider an electromagnetic radiation, it is created when an atomic particle, such as an electron, it is accelerated by an electrical field. So when you apply an electrical field, the electron, it starts accelerating, and due to this acceleration, it leads to movement of the electrons, and this movement of electron, it will lead to formation of oscillating electric and magnetic field, means both the magnetic field will be oscillating. As a result, it is a movement of both the fields in a particular direction, which travels at right angle to each other, and it is traveling in the form of a bundle of light energy, which is known as photon. So as we have discussed earlier, that light, it is one kind of energy which is in the form of electromagnetism. This traveling electromagnetic radiation, it is associated with energy, and this form of energy is basically known as electromagnetic radiation energy. This electromagnetic radiation energy, it is categorized, or it is classified on the basis of its wavelength into a spectrum which is known as electromagnetic spectrum. So if you consider an electromagnetic spectrum, it will lead to formation of various different light or various different radiations associated with different amount of energy, and this different amount of energy is based upon its wavelength. These electric and magnetic waves, they travel perpendicular to each other, and they have some peculiar characteristics which includes amplitude, wavelength, and frequency. So amplitude, wavelength, and frequency are some important characteristics of electromagnetic radiations. Now, if you see the diagram which has been shown here, we can see that the electromagnetic radiation or an electromagnetic wave, it propagates in the direction of the x-axis, while the y and the z-axis, it corresponds to the flow of or oscillation of the electric field and magnetic field respectively. In the second diagram, we can see that it has been depicted that one wavelength is the length of a wave which will include a consecutive crest and a trough, and there is an amplitude which has been shown here. Amplitude basically can be considered as the height of the wave. Now, if you see the diagram which has been shown below, where lambda is considered as basically the wavelength, capital E is the amplitude of the electrical field, and M is the amplitude of magnetic field. Basically, amplitude is associated with energy. Higher the energy, more will be the amplitude. Lower the energy, the amplitude will be also lower. The height will be lower. The wave height will be shorter or lesser. Now, coming towards the general properties of electromagnetic radiation. Now, electromagnetic radiation, the basic property is they can travel through space. Most of other type of waves, they travel through some sort of substances. Means there is some sort of media which is required for traveling of many different types of waves. For example, if you consider sound waves, they either need gas, solid or liquid to pass through in order to be heard. The speed of light will always remain constant. The wavelength, it is measured as distance between a crest, two consecutive crest or two consecutive troughs, and it is characterized by a Greek symbol which is known as lambda. So basically, if you consider, these are the general properties of electromagnetic radiation, that is, they travel through space. Other types of waves such as sound waves, they need some sort of substance or media so that they can travel. For example, they need gas, solid or liquid to pass through in order to be heard. The speed of light, which remains constant. Wavelength, which is measured in the form of distance between either crest or trough, and characterized by a Greek symbol which is known as lambda. So these are basic properties of electromagnetic radiations. Now, when we consider waves and their characteristic, because as we have gone that electromagnetic radiations, they propagate in the form of electromagnetic waves, and that's why it is necessary to understand the form of wave and their characteristics. So the first important characteristic which we need to study here, it is the amplitude of the wave. What do you mean by amplitude? Now, amplitude, basically it is a distance from the maximum vertical displacement of the wave to the middle of the wave. It is maximum vertical displacement. This measures the magnitude of oscillation of electrical field as well as magnetic field of a particular wave. Amplitude is basically the height of wave. As I have shown earlier in the figure, we can consider that height, it shows the amplitude, and it is connected with energy. The larger the amplitude means higher energy, means the height will be more, whereas lower amplitude means lower energy, the height will be lesser. Amplitude is important because it will tell you about the intensity or the brightness of the wave in comparison with other waves. So it is, if you compare two different amplitudes of two different waves, then by looking at the amplitude, we can decide that what is the intensity of the radiation which is coming. Hence, we can consider that amplitude and energy, they are proportional to each other. That is, if amplitude increases, energy also increases, or vice versa. That is, if energy is more, the amplitude of the wave will be also more. Coming to the another important characteristic of wave, that is known as wavelength. Now, wavelength, it is designated by lambda. It is distance of one full cycle of an oscillation. So wavelength is distance between two consecutive peak of a wave. It's given in terms of meters, or it is measured in terms of meters. It is only a distance which has to be measured between two consecutive peaks. Longer wavelength, such as radio waves, they have lower energy, and that's why we can listen to radio waves, and they are not at all harmful in any consequences. Shorter wavelength, such as X-rays, they carry higher energy that can be hazardous to our health. So basically, if you see, shorter wavelength of radiations are associated with higher energy level, whereas longer wavelength of radiations are associated with lower energy levels. Now, if you consider that the relationship between wavelength and a frequency relationship, it can be given by an equation known as C is equal to lambda nu, where c is the speed of light, lambda is the wavelength, and nu is the frequency. Looking at the above equation, we can say that lambda and nu are inversely proportional to each other. That is, wavelength and frequency are inversely proportional to each other. Higher the wavelength, lower will be the frequency of the radiation, or vice versa. If the frequency is higher, then the wavelength of the radiation would be lower. And shorter wavelength means greater frequency, and greater frequency means it is associated with higher energy levels. In the next class, we will continue with other different characteristics of the wave. Thank you.